Hello class. For the next video, I want to extend the previous video I created for press fit. Let me open the previous simulation we had. It was a pipe and we press fit softer geometry inside it. But imagine if you had a geometries, or you had a design, it was outside, consider a building. You are going to design a building facade, and that building facade is going to have some holes, some connections, some contact. Different parts are going to have contact. They could have the same materials or different materials. For example, nowadays, because of advances in we have for facades, we have like a dynamic facades, and there are some parts they can move. Those movements sometimes is because of the electrical equipments, like a small electric engine there to move different parts, or sometimes because of the temperature change. For example, in a summertime when temperature is high, they create some connections and add some materials which they are sensitive to temperature, so they length increases and they increase shade over the building or decrease the shade. Anyway, I just want to tell you, when we have a connection, we could have the effect of temperature. Now I want to include that effect. Let me open the model. This is the exact file we had for the previous video. Okay, this is the whole simulation. Add a little bit. What is going to happen to the whole system? So let's add the effect of temperature. I'm going to add thermal condition for pipe, because metal is going to expand more and it is going to be more sensitive to the temperature. The current temperature 22 degree I accept as a like an environment temperature, and because I want to create a big difference, so let's go with 200 degrees. So all of a sudden I'm going to increase this temperature to 200 degrees. I haven't made the decision how I'm going to change the temperature, because currently I just assigned that temperature. So to make a decision about how to apply temperature, I need to go back to analysis setting and the number of steps. Originally we had one step, but which was just because of the overlap. During that one step, which we had 1 second simulation, gradually we had overlap, and ANSYS gets rid of that overlap. By getting rid of that overlap, pressure and temperature created, and we had all the calculations. Now I want to create 2 steps. Okay, let's go to the temperature condition. Now I can see originally 22 degree. I don't want to, for the first part we had a temperature effect, so I'm going to keep that 22 degree, and then ask ANSYS to increase to 200 degrees. So so and I'm applying the same thing here. 10, 10,000. So it's going to be very gradual, and large deflection is on, and I'm happy with the rest. Okay. Do I need to change anything? No, everything is okay. So I just applied temperature for the second step. We had two steps. First step, we are going to have everything exactly like the previous video. Second step, temperature effect is going to be applied. Let's solve it. I'm going to show you forced convection, convergence, and let's see. Early stage, it is difficult for ANSYS to converge, so it starts with large difference, 21, and the criteria is under 0.001. But very fast, we had a little bit first convergence, so that is why our time is going to be to continue, and we are going to increase the time, simulation time. We need to reach 2 seconds. First second is going to be just effect of press fit, nothing else. From second 1 to 2, we are going to gradually increase the temperature of outer shell for the pipe and see what is the effect. first second finished. Now we are going to have the effect of temperature. Okay, simulation finished, and let's see what happened. This is our simulation after finishing. Let me increase the size of this side. Okay, gradually the, where is it? This is stress, yes. The maximum stress gradually increases till second 1, the first second, which is 176.1. This is the exact value we found for previous video. Then we apply temperature and increase it to 200 from second 1 to second 2. As you can see, the maximum stress decreases to 127. So by increasing temperature of the pipe, the pipe is expanded and the overlap decreased, and that is why the stress over that pipe decreased. So let's see strain. Do we have the same trend? Up to second 1, yes, and then it is going to decrease again. What about deformation? Up to second 1, it increases, and then after that, deformation decreases. Up to first second, we have 0.19, and then it is decreases to 0.18 millimeter. So temperature helped us here. Let me check the safety factor. Remember what was the safety factor? It was 0.56. So the minimum safety factor which we are looking at first second is 0.56, and then by applying temperature the safety factor increases up to 0.79, which is good. Let me check contact and pressure, frictional stress and pressure. Let's check those two. So first of all the parts are stuck to each other, so no sliding for this contact, which we expected because we already considered the the material, the polymer is inside the pipe. If we try to move it, yeah, we may see some sliding parts too. But for this condition, it's all just sticked to that. This is our frictional stress. Let me create a video and check this frictional stress. Okay, it is increases. Now a little bit decreased because of the temperature increases. Very interesting. What about pressure? We should see the similar behavior. From time 0 to 1, pressure should increase. As we can see, pressure increases, more, then now decreases because of the temperature. Okay, so this condition was for the case we had everything here. So instead of this frictionless support I applied here, I could apply displacement for the inside, for the insert object. And for example, ask object to move 5 millimeter inside this pipe. And we are going to have different behavior. And this type of simulation would be when we are installing this insert object inside this pipe. So if you want to simulate the installing process, what type of pressure and stress we are going to have, you can use this displacement of the insert object inside this pipe to get the stresses. If it is not important installation process, you just want to see what's the long-term behavior when it is already installed, you can use the one I already simulated here. Okay, I hope this was interesting. See you next time.